Hi friends, in this other tutorial we are going to be looking at fixed length subnet masking. We are going to look at what is subnetting, what do we mean by borrowing bits, what is a block size, and we'll look at a practical example on how to subnet a network. So let's get in and discuss on what subnetting is. What is subnetting? Subnetting is the process of dividing one large network into a smaller, separate network segments, which we usually call subnets. So subnetting is that process of getting a big network and breaking it down into a small and manageable network. Without subnetting, we just have one big network, which is a flat network, and all, for example, if you're looking at class C, that means all the 256 or 255 hosts are on a single segment. If it is class B, that means the 65,534 addresses are on one network. And worse, if you're on class A, that means those 16,000,000.7 addresses, they are all on one network. If it's an organization, maybe you have different departments like finance, library, labs, everything else, everything sees everything else's network. Like they all share the network, they all use the same network. And so at the end of the day, there may be a lot of traffic. So one broadcast, imagine if one computer sends out a broadcast, that means it has to send all to the 65,000 addresses, all to all the 256 addresses that are available on the network. So this initially makes it hard to manage, hard to secure, it becomes congested, the network becomes slow, a lot of traffic, management traffic, you know, once one network is corrupted or it is down, it is not segmented, so it slows down your network, and it's not a good networking principle. So what we do, we can get our big network and we break it down into a small and manageable network. So with subnetting, you will have finance on their own department. You have for example, library in their own network, the labs in their own subnet, and the admin in their own subnet. That is what we call by subnetting. And there are usually two ways we subnet. We can subnet using the fixed length subnet masking, which we are talking about now, or we can subnet using the variable length subnet masking, which we shall discuss later. Fixed length subnet masking means that when you are creating your small networks, every network has the same size, same number of hosts. That's what we mean. The same masks, same number of hosts, same block size. That's what we mean. So we can get one big network, for example, and we break it down into 4 equal sub-networks. That is what we refer to as the fixed length subnet masking. So the key point about fixed length is that all our networks we are going to create, they must be of the same size, having the same number of usable hosts. Even if one department, for example, like you can see up here, has only 5 devices, or the other has 60, with fixed length, it doesn't matter. They all have the same space, they have the same size, and this means that some networks or subnets will have addresses left over that are never used, and some may have wasted addresses, and this is a trade-off for fixed length subnet masking. That's why in modern networks they prefer using variable length subnet masking. So what is all this subnetting we are talking about? We are saying when we are subnetting, you subnet when you borrow from the host portion and you give the host portion to the network portion. It's called borrowing. Remember in our earlier discussions, we said when you're looking at a subnet mask, the network bits are represented by ones. These network bits you'll see. And the host bits are represented by zeros. Very important to remember. So what happens here is that for us to create networks, for us to subnet, for us to create subnetworks, we need to borrow from the host portion. We need to borrow from some bits here from the host portion and allocate them to the network portion. So here that means that if we had initially 24 network bits and we go ahead and borrow 2 bits here, we are going to now have a total of 26 network bits. So that means we have borrowed 2 bits from the host portion and we have allocated them to the network portion. So initially we had 24 ones, now we have 26 ones. So if we borrow 2, what does that mean? So for us to determine the number of networks we have created, the other name I can use for subnet is networks. For us to determine the number of subnets I've created, we use a simple formula of 2 to power s, where s represents the number of borrowed bits. All right, the s can be b, it can be any letter of your choice, but just remember that here when we are determining the number of subnets, our formula is 2 to power the number of borrowed bits. In this example, we have borrowed 2, so if we have borrowed 2 bits, that means we shall create a total of 4 subnets. Now, for us to determine the number of hosts per subnet, the number of, now we have created 4 networks. How many hosts are available on each of these 4 networks? For us to determine the number of hosts per these subnets created after borrowing 2 bits, now we use our normal formula of 2 power h, where h represents the number of host bits. So in our case, initially for a class C network, we had 8 host bits. But because we have lent them to the network portion, we no longer have 8. We have borrowed 2 to the network portion. That means we shall get 8, the initial one, minus 2, and now we have a total of 6. You can even count 1, 2, 3, 4, 5, 6 bits. So this means that we have 8 minus 2, so we shall have a total of 6 host bits, and then we shall have each network having a total of 62 valid host addresses. So basically that's what it means. You create networks, and those networks you have created each have the number of hosts that they can use. So these are the simple steps you can take for you to successfully subnet. For example, assuming we had an IP address of let me get this one here. Assuming we had an IP address of 192.168.20.0. So these are steps we're going to follow, friends. We have an IP address which is 192. Let me write it here. So we have 192.168.20.0. That is our IP address. So when we look at our steps, the first thing we ask ourselves, how many subnets do we need to create? Sometimes this is a question that is given to you. They tell you create 4 networks, or create 3 networks, or create 5 networks, or create 2 networks. And we have seen that we borrow bits for us to create networks. So in this particular scenario, they're asking us, or we're asking ourselves, how many subnets do we need? How many networks do we need? Assuming we wanted to create 4 networks, then that means that we need to create 4 networks. So that is very important. And we do this by determining how many host bits should we borrow for us to take it to the other side. So the first step here, we have determined we need to create, let me just change my color here to red. So we have determined that we need to create 4 subnets, isn't it? And after us creating 4 subnets, we're asking ourselves, how many bits do we need to borrow for us to create 4 networks? So the first thing you do, you ask yourself, which class is this? Which prefix is it having? This is an address in class what? Class C. Very good. So if it is class C, it means we have our network bits and our host bits. Class C has 24 network bits and 8 host bits. So What is a default subnet mask for this class? It's the first thing you should always write down. In this case, it is 255.255.255.0. And we can even convert this into binary. When you convert 255 in binary, it will be 1, 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, 3, 4, 5, 6, 7, 8 dot 1, 2, sorry, this is supposed to be 0, 1, 2, 3, 2, 3, 4, 5, 6, 7, 8. This is our subnet mask in binary. We have determined the default subnet mask, and before we have borrowed, we can see already that we have a prefix of 24 network bits. So for us to be able to subnet, we need to borrow bits. So we are asking ourselves, 2 to power what? We said S, which represents borrowed bit. Shall we get, right, a number that is almost equal or greater than what we are looking for? We are looking for 4 subnets. So 2 to power what, in other words, shall we get 4 subnets? And in this case, it is 2 to power 2, where we shall get 4. That means we need to borrow 2 bits. Now, these 2 bits here have to change, right? Have to change from being ones now, and they're going to represent the network portions. Let me write them in black. So we have borrowed 2 bits, these ones here. We have moved them away, and now they're representing the network, because they say the network bits are represented by 1, the host bits are represented by 0. So we have subnetted. The initial one was 24 network bits, the initial one now. Before subnetting, class C had a total of 2 to power 8, where we get 256 addresses, isn't it? And the total is 254 if we subtract the 2 valid to get the usable addresses. So now that means for us, if we have borrowed these 2, we have created 4 networks. And the question is, how many addresses are now available on each of these 4 networks that we have created? So we are going to say 2 to power host bits. And what is our new host bits for our new networks? We have 1, 2, 3, 4, 5, 6. So that means we have 2 to power 6, and we shall get a total, 2 to power 6, we shall get a total of 64. For us to get the usable, we subtract 2 and we get a total of 62. So meaning each network will have a total of 64 addresses, the ones that we have created. Another question might be, what is the new subnet mask for our newly created subnets? The new subnet mask is very simple. We have it here in binary. This was 255, so we just convert it back to 255.255. This represents which value? Remember our scale. Always remember this scale: 128, 64, 32, 16, 8, 4, 2, and 1. Always. So this first bit represents the 128. This other one represents the 64. The others are 0. So we don't consider them. We only add 128 plus that, and we get a total of 192. So our new subnet mask will be 255.255.255.192. That is our new subnet mask. So a question may come, and they are requiring us now to fill in our address table for these particular hosts we have created. The subnet mask, we know for all these networks, as long as we are looking at a fixed length, it will not change. So it will be 255.255.192. That is our new subnet mask, isn't it, friends? Because it's what we have just calculated. Now the prefix, it is also simple for us to get it, because when you look at the prefix now, initially we had 24 bits, if you remember. But because we borrowed and added them 2 more, 24 plus 2, you get a total of 26. So our new prefix will be 26. And because it is fixed length, this doesn't change. So it will be the same story here. It will be the same story here, same story there. However, if we were looking at variable length, you'll notice that the subnet mask was going to change was going to change. Now, for these two networks, what is our network address? Now we have started filling in this particular table. What is our network address? We come back to our calculation here. Already, the first network that we had here is our network address, which is 192.168.20.0. So I'll come to my table and then I'll fill in my network address 192.168.20.0. Now, it is important for me to just first calculate all the network addresses if I'm using fixed length, and then I can get these others. Now, the next network address will start immediately where the other one ends. So it will be a total, remember each network is having a total of 64 addresses. Remember what we calculated here, where we said 2 to power h, and realize that h now is how many? 6. And 2 to power 6, we are going to get 64. So meaning each network will have a total of 64 addresses. So if you count 64 from this will be 192.168.20.64. And then when you go ahead and count 64 on this as well, if you add, let me just open a simple calculator here, and we add. I just want to get all my network addresses. I think the easiest way. So here I have 64. I'll go ahead and add 64, and then I'll have my next IP address, which will be 192, and here it's going to be 128. On 128, I'll go ahead and add there my other 64, and then my other network will be 192. All right, so I have 064, an increment of 64. Now, on the first subnet, for me to get, let me even highlight, for me to get the first usable IP, I just need to add 1 onto my network address. All right, so let me come here and add 1. This one is this, so I just come here, add 1, so it will be .1. And then for me to get the last broadcast, I get my next network address for the next subnet, and I subtract 1. So I'll do 192.168.20.63. That is my last one. So to get the last valid one, I also get my broadcast and I subtract 1. So this will be .62, like that. So with the network address, I add 1. Subnet broadcast, subtract 1. So I have filled in my table. Go to the next one. What is this plus 1? It will be .65, right? What will be my broadcast here? It will be this one minus 1. So it will be .127. As simple as that. And then this one will be 126. So I get here, fill it in, and this will be minus 1 of the broadcast. So I have it there. So what will be this one here? I come here, put it in, and then this will be 191. What is my next first usable address here? It will be 29. This one will be 90. As simple as that. You see, calculate one as long as you get the first one right with fixed length. The others are easy to get. Here it will be 93, right? So 93 here, and then this one here, you can add 64 onto this, but we shall get a total here of 255 when you add 64 onto this. The last one, always the last octet should be 255. If it's not 255, then you have made a mistake. You need to cross check and find out if what is wrong with your working. So now this one will be 254 is our last usable address, and our table is filled, and you're done with subnet masking. So each network will have its prefix. Important to note that with fixed length, all the subnet mask and prefix is the same. What changes depending on the number of hosts you have got. You just keep incrementing them for the network address, and even it's the same here. You just keep adding 64. So 63 plus 64, you get 127. 127 plus 64, you get 191. 191 plus 64, you get 255. And then once you have the broadcast and the network, you can get always the first usable IP and the last usable IP, or the first valid or the last valid IP. As simple as that. So basically that is what you go through, and you work through your table and you get such until when you get the last answer that you wanted to look for. So this is the answer that we have looked through, and the number that we have tried out. But what you should take away from this tutorial is a subnetting. You're getting one big network, you're dividing it into smaller separate segments, and if you use fixed length, each subnet is the same size, same network mask, same block, same host count. And we do this by borrowing from the host portion and allocating to the network portion. And so the original prefix will be plus the borrowed bits, and then we can have the same block of usable IP address, and then we can now fill in our table. This is simple, but it wastes addresses when departments have different sizes. Maybe in the CEO's office, there are only 2 computers, and now we have allocated there, assuming 64. So we have wasted the other 62 addresses in that regard. So basically, that is what we wanted to discuss now, and we shall look at now variable length subnetting later on, which is very important. Please ensure that you look out for that video, because variable length will give you a clear picture of how do you now subnet and create different networks when you have different needs. Thank you so much for listening to me, and I hope you enjoyed the video.